Before moving towards the Kubernetes, we'll talk about Docker, why we need Docker, and what are its components. And yeah, containers are the building block of Kubernetes. So yeah, starting off, first, why do we need containers or Dockers? So suppose you're building an application or service, the basic thing is you need some libraries, you need dependencies. These are actually tightly coupled with your operating system. It depends what kernel you have and what kind of version of libraries you have. And suppose you build your application, Node.js application or Django application, and it works really fine on your application. But when you deploy it in the production or you pass it on to your friend, and when he runs your application, it breaks. Because he might have different versions, different operating system, which this gives rise to incompatibility. That's what Docker tries to solve. Basically what it does, it packages all your dependencies, libraries together so that you can share your code and deploy it anywhere. So it makes sure that if your service or application is running on your host machine, it will run on production or deployment or on your friend's host too. So how it does is it isolates. It isolates your application. It isolates your processes, networks, and mounts. These are some of the things. And yeah, next we'll move how is it different from virtualizations. You can tell me, you can ask a question saying that we can do the same thing with virtual machine. Even virtual machine does the isolation, right? So I'll talk about the difference between containerization versus virtualization. And yeah, first virtualization, as we all know, we have created virtual machines. The main difference is each VM, they have their own operating system, different kernels. They don't share kernels. But in containerization, as you can see, there is only one operating system. And all the containers which I will be creating, they'll share the same operating system. But in case of virtual machines, they have their own operating systems. The cons of this is that it requires more CPU, RAM, and more resources. But since containers are using the underlying operating system, it actually uses less resources and it's easy to start them and shut them down. That's why we prefer containerization over virtualization. But again, virtualization, it has more security because everything is isolated over here. But here you are using the same operating system, so there might come some security concerns. And again, since I told that they are using the same operating system, so you can't actually run Windows container on a Ubuntu or Linux. If your host is Linux kernel, you can't practically run Windows because in containers we are sharing the same operating system. Suppose you have a Ubuntu host machine, you can deploy Debian, Fedora, because these share same kernel, which is Linux. But Windows is different, so that's one of the downsides. You can't do that in containerization. But in virtualization, since they have different operating system, you can have in your same machine you can dual boot. I think you can have Windows as well as Ubuntu and stuff. So that's one thing. Yeah. So how does this containers work? What makes them so special? How does the isolation happens? So we have something called as C groups and namespaces. C group is basically to manage resources. You can manage how much CPU the container is using, how much RAM it is using. So that's what C group is. And then you have namespaces. Basically, namespaces is to isolate your processes. You will have different process IDs. You have different network interface. So namespaces gives you isolation. And again, it gives you sandbox environment. If your container fails, it doesn't affect your host operating system. Yeah, that's why it is sandbox environment. And yeah, it's not a VM. We can tell it's a lightweight VM in layman's term, but it's not exactly a VM. Yeah. And yeah, container engine is the one, as you can see here, which creates containers. In our case, Docker provides container engines. Docker is not just container engines, it has set of tools. Container engine is a part of that. Okay? And Docker is not the only one who does containerization. We have other companies too which do containerization. So Docker is the most famous one. So we'll go with Docker now. And yeah, we'll have some terminologies. And first, as I told, we can have your application running on your host. How do you create containers? That's what we call. Containers, again, they are just isolated environments. Okay? And how do we create them? We create them from images. Images are, again, they are package files. They are like snapshots of your containers. When you run them, you get container. And again, you can ask me how do you create images. You do it using Dockerfile. Dockerfile are nothing, they are just text files. They are like a recipe where you define what base OS you want and what kind of command and packages you want in them. I will show you an example in a minute. And yeah, I will just show the example of a Dockerfile. Okay. Okay. Yeah, let me scan it. How do you zoom? I hope, yeah. So this is one of the example of a Docker file. You have to specify the name D with capital, and that's the rule. Coming first, if you want to create your custom image, there are already a lot of images present. You can go to Docker Hub and you can get those images. But if you want to build your own image, then you can't build it from scratch. You need a base image from where you start your building. So here it's from Node, and Carbon is just the version. Node is just an example to run JavaScript. It's a runtime environment. So basically, what this means that I don't have Node currently in my system. Oh, it's there. Okay. Oh, I have Node even in my local host. That's fine. Okay, so we are creating a new custom image. So we are taking Node. That means Node will already be installed. Again, Node will be created by the creators. They will have a base image like Ubuntu or Debian. Upon that, they will install Node and stuff. And then run command. It runs your command on the image. Is it fine? I think more. Sorry. Yeah. So we are having the base image as Node, and then we are just running a custom command inside that pre-built image, which will be like we are just making a directory for hello world. And we are talking a file called helloworld.js and package.json, which I already have in my system. I'm just copying it to the container. And then we are just working directly. We are just telling the container that once we enter into this container, this will be the working directory. And then we are using npm install. We use npm to install the dependencies. Expose 3000. Expose it, that just exposes the port 3000 because the application is running on 3000. So if we need to access it, we need to expose the 3000 port. And entry point is just the command. When you start the container, what first default command do you want? That's what you put into the entry point. So yeah. Now this is just a Docker file. But as I told, if you want to make a container, you need to have an image. So this is our recipe. Now we'll just make the dish, which is the image. So yeah, the command is docker build -t and image name will be example. The dot indicates we are telling it to look the Docker file in the current directory. Oh. So it's building the image. It first checks locally if I have that image in my host. If it isn't, it takes it from the Docker hub. That's what it doesn't have it locally. That's as you can see, it has taken all the images layers from the Docker hub, and yeah, it's building. Once this is complete, next time when you try to build any custom Docker, any custom Docker image which has node, it will be fast because all the layers are already cached. So it will take from your local host. Yeah, it's running the command, all my commands. It is installing the dependencies. Right now the container is there. You can't see the container, but it has started the container and it's running the commands inside the container. And that's it there, it's done. Now the image is created. So where can you find the image? Where? So the command to see your images are docker. Yeah, this gives you a list of all the images which you have locally. An example, yeah, this is the, as you can see, this is the one. Every image has its image ID. This is what we use to locate the image. So this is our image. Now we need to start the container out of this image. Before this, let me just show you what those files had. Yeah, cat hello world. Where am I? Yeah, cat. Yeah, it's just hello world application which is written. So this is what we are trying to show. And now we have the image, we created the image, now we have to make it into a container. For that we have a command called docker run. Docker run -p. We need to do port mapping because as I told, Dockers have their own network namespaces, which means they will have their own IP addresses, gateways. So which is kind of different from our computer. And if somebody tries to connect to the application which is running inside the container, it's not running inside our host. It's our host is there, upon that there is container, and then there is application inside that container. So it should go through our host. So we have to port map our 3000 to the 3000 of the container, because that is where the application is running. And previously when I told, that's why I had exposed 3000 so that anyone can connect to the port. So whatever request is coming at our 3000, the local host, will be directed to the 3000 of the container, which will start now. And then we should give the name of the image, which was example. Yeah. Yeah, as you can see, hello world. So right now I am sending the request at my local host, and it's 3000. So whatever the request I am sending to my local host, it is actually going to the container. The application is not running on our machine. Let me go inside this container and show it to you. In order to go inside a container, we have something called as docker exec. Actually, you can just write the first four letters of or numbers of the image ID to access it. You don't need to write the entire name. As I can see, it's FCB8, and you can access it. I'll run through bash. Minus IT, I means interactive, T means terminal, so I'm just telling it I want it running here. So let's go inside our container. So yeah, this is our container. We are inside the container. If we see the files, these were the things which we had copied from our local host to the container, and yeah, and this was the directory which we copied. It has npm, yeah, it has node, yeah. So this is the version in the container, and I can just exit it with exit command. On my local machine, the node version was, yeah, as you can see, there are two different versions. So this is what I meant when I told you can package your dependencies. And yeah, moving on, the next thing is we will look at the networking part. So every Docker has its own IP address, and we have something called as network bridge. Yeah, it's just, we have different type of drivers. We have bridge, we have host, and we have mail. These are three different types of bridge. You can specify which bridge driver you want. By default, it's going to be bridge. When you specify host, it basically means that there is no difference between the Docker network and your host network. Your Docker is using entirely your host network. It's kind of attached. But when you use bridge, the container network is different from your host network. So in order to see which driver your container is running on, we have Docker inspect command. Docker inspect command, again, it gives you details about your container. So we can again Docker inspect and the container name. Yeah, this is a huge file. Let's start from, it just says ID, create path, arguments, which we had given in the entry point, and it has bunch of other informations. We need network, okay, port binding. As I told, we had binded the 3000 of our local host. That's what it shows here. And moving down, I want to show networking part. Where is networking part? Configuration, host name, domain. Yeah, network setting. It is using bridge network. You can modify it to use whatever driver you want, and you can host. It has, this is its IP address. If you have multiple containers, these containers can talk to each other just by their container names, because Docker maintains its internal DNS. So that was the networking part with respect to Docker. Yeah. Yeah, that's it with Docker. If you had any doubts. Any doubts? Yeah. Thank you.
Hello guys, I'm Chinmaya. So that was containerization. That is like the prerequisite for what we're going to do next, which is Kubernetes, which is a container orchestration platform. So so why exactly container orchestration is needed? Yeah, so as we saw, we can deploy services in nicely packaged containers, which makes our workflow much easier, and it also gives like a nice sandboxed environment for our services. Yeah, I know. Yeah, so why do we need container orchestration? So in big companies, they'll be running like millions of containers at the same time, and they would have to like manage and handle all of these containers. They would so if you use container orchestration, you can automate the handling and scheduling like a large number of containers. So also in case of node failures, like in case any system goes down or anything, then if there is no container orchestration running, then you would have to manually go and restart the container and do all of that. So if you have container orchestration, that is automatically handled. Also, when new versions of your applications are released, then container orchestration makes it simpler to roll new versions out. And then also for high availability, it's the thing to use. So like I said, when some nodes go down, then your application will still be running, because Kubernetes is able to detect that, and it is able to restart the container elsewhere. Yeah, so this is the Kubernetes architecture. I won't go in much depth. I will explain the basics of this. Internally, it is extremely complex. So there is something that is central running in Kubernetes called Kube API server. So this is like your average API server. It has multiple API endpoints where you can just do get or post requests or things like that. So the Kube API server uses something called etcd, which is a distributed database. So what happens is, if you want to create like a component in Kubernetes, like an artifact in Kubernetes you want to create, you make a request to the Kube API server, and it will store the information about the component in the database. So it works basically like your average website. So it will just store that information in the database, and then there is something called controller manager, which actually keeps asking Kube API server whether it has to do something. And once an entry is made into the database, it will come to know that it has to like create certain components in the cluster. So it makes a GET request to the Kube API server, which lets it know that okay, you have to do something. So it takes that as a sign to like create components in the cluster. And then there is something called scheduler. So what scheduler does is, because there are multiple nodes in your cluster, there needs to be a component running that decides where to schedule a container in which node. So the scheduler takes care of that, and it too communicates with the cluster using the Kube API server. So the central component is the API server, which manages intercommunication between different components in your cluster. So coming to the nodes, so this is the control plane where which is managing most of your cluster components, and then you have different nodes that are connected to the control plane. These are worker nodes. This is where you deploy all of your applications in containers. So Kubernetes has a kind of abstraction called pods. You can consider pods to be like equivalent to containers for the moment, but actually in pods you can run multiple containers that need to share certain resources. So pods make use of the container runtime. So container runtime like Docker that we just went through. The nodes make use of this container runtime to like run the containers in pods. And there is something called kubelet, which is responsible for managing everything in the specific node, like all of the networking and everything. Yeah, so these are the nodes, and then the communication with the cluster from the external network happens through something called a load balancer. Yeah, and there is something called kubectl, which is which communicates with the Kube API server. We'll be going through kubectl in a moment. I'll be demoing how to use it. And then coming to pods. Yeah. So like I said, a pod is an abstraction in the cluster where you can run multiple containers. So this is where you run most of your services. And as you can see, there is Kubernetes has its own network, that is cluster network, that is created, and each pod is assigned its own IP, and the containers in the same pod share that IP. Yeah, I'll just demo running a pod in the cluster. So yeah, coming to there is something called kubectl. So I am running something called kind, which is a way to run a Kubernetes cluster in Docker. So in real world situations, you use multiple virtual machines, and one of them is a control plane, or two of them are the control plane nodes, and the others are worker nodes. So in real world situations, you do that, and you run containers in each of those virtual machines. But in your local machine, that would be very tedious to set up. So there is something called kind, which lets you run containers inside containers. So that is a complicated topic that we are not covering here, but all you need to know is here instead of virtual machines, you are just running containers as nodes. So if I do Docker PS, you can see something like this, which is kind control plane. So this is like a one node cluster, a very simple cluster. You can have multiple nodes in your cluster. That is also a configuration that is available in kind. Yeah, so the kind control plane is running. So now if I do kubectl get nodes, yeah, so you can see this being labeled as a node. So it is running this is a Kubernetes cluster basically, which has one node. Yeah, and the role is control plane. Now if I do kubectl get pods, which are the pods running in the cluster. Okay, wait. So I'm just deleting the my pod from the cluster so that I can create it again to demo. So showing, so how do you create a pod in your cluster? It is basically like Arfath talked about, running a container locally. You do Docker run, and you give the name of the image. So in Kubernetes, how you run a pod in a cluster is you create something called a manifest. So this is a very simple Kubernetes manifest. You specify the API version, which is like the Kube API server has different API versions which are related to different components that you want to create in the cluster. And the API version that is related to the pod is V1. And this has a lot of complicated concepts related to this, like there are different API versions available, and the naming follows a certain convention. And then you specify the kind of the component that you want to create. So that is a pod. And then in metadata, you specify the name of the pod, and then you specify the labels. The labels I'll get to later. These are important for other services that you want to run in your cluster. And then coming to spec, this is where you define all the containers that you want to run in your pod. So I'm going to name my container that I'm going to run inside this pod as my container, and I can run nginx here. So if I do kubectl create -f pod.yaml, yeah, so a pod has been created in my cluster. So if I do kubectl get pods, I can see my pod is running. So as you can see, it is running and it is running in the port 80, and that is what is exposed. But if I go here, if I can't access this directly in my local host, because this is running inside the Kubernetes network. So in order to make it run in my local host, I can do something called port forwarding. So all I have to do is, if I do this, it does port forwarding from inside the Kubernetes network to my local host. So I can, do this, and welcome to nginx. So I can access, now I'm accessing nginx that is running inside a pod in the cluster. Yeah, as you can see, it shows when I am accessing the Nginx web page. Yeah, so that's basically a pod. Yeah, coming to the next topic. Yeah, so I hope everyone understood what a pod is. Does anyone have any doubts? Yeah, basically it's like a container, but in Kubernetes, you are allowed to run multiple containers in one packaged artifact called a pod. So coming to healthy pods. So you want to run pods that are healthy, meaning if a pod goes down, you want your cluster to restart that pod so that you can make your service highly available. So there are multiple ways that Kubernetes provides this feature. One thing is called liveness probes, which is basically something that you define in your pod manifest. You define like a health check kind of thing, which probes into the specific port that you want it to probe into, and then it checks if that service is still running. And if it is running, then it doesn't do anything. But if it is not running, then it will delete the pod and then it will restart the pod. Coming to replication controllers, so that is another component of Kubernetes. There are something called replication controllers, which you define in a cluster that will help you manage all the pods in your cluster. So this is how you define a replication controller. You define a pod selector. So as you guys saw in the pod manifest, there is something called a selector that you define for a pod. And then in the replication controller manifest, you define a pod selector so that the replication controller will know which pods to manage. And then you define replicas. So the importance of this is, the significance of replicas is it will know how many pods to keep running in the cluster. So it will keep querying the Kube API server, how many pods are running in the cluster. Are there 2 pods running? Are there 3 pods running? How many pods are running? And the Kube API server replies, okay, 2 pods are running. So the replication controller will know, okay, I need to run 1 more pod because my manifest says I need to run 3 pods. So that's the significance of this replicas. And then you also provide a pod template so that when you create a replication controller, it will create those pods for you if those pods are not already running in the cluster. Yeah, so this figure basically shows what happens. There are 2 nodes here, and pod A and pod B are being run in these 2 nodes. And replication controller basically manages pod A and pod B. So if node 1 failure happens, then it automatically schedules the pods that were running before and it was managing, but now aren't running anymore because of node failure. To keep them running, it schedules them in the other node. All this happens with the conjunction of Kube API server, the scheduler, controller manager, which the replication controller is a part of. Yeah, coming to the demo of a replication controller. Yeah. Yeah, so this is basically the manifest for replication controller. You specify the kind, which is replication controller, the metadata, the name of the replication controller, and then the specification. So here you define the number of pods that you want your replication controller to manage, and then you specify the selector, and then you specify the pod template. So from here onwards, this is very similar to your pod manifest. As you can see, yeah. You just don't specify API version and kind because that's already understood. From metadata, everything else is very similar to the pod manifest. That is the template you are providing to your replication controller. Yeah, so this will manage 3 pods that are running Nginx. So I can basically run, create this 1 minute. So I can check how many replication controllers are running in my cluster using kubectl get rc, and I can see that none of them, no replication controllers are running in my cluster. So yeah, so our replication controller has been created in the cluster. Now I can do kubectl get pods. Yeah, so basically here it only created 1 new pod. The reason for this is there were already 2 pods that were running with the label with this label, with this label my app. So it only created one more pod because I specified that the number of pods that it should manage is 3. So it would only have to create one more pod. So let's check what will happen if I delete one of the pods. Yeah, so I deleted one pod. Now if I do kubectl get pods, you can see that it started one more pod here, because it always has to make sure that there are 3 pods that are running in your cluster. So I'll delete the another pod here. Yeah. Now you can see that all 3 pods are have been created by your replication controller. Now if I do kubectl delete the replication controller that I just created, then all the pods that it used to manage have disappeared, because your replication controller is gone. So that means it tells the cluster to remove all the pods from your cluster that it was managing. Yeah, so that's basically replication controller. Yeah, so there is another feature which lets you scale your replication controller. So I'll just create replication controller once. Yeah, so there is a command called kubectl. Kubectl get pods. You can see 3 pods that are running. I'll run kubectl scale rc my rc. So I'm specifying it that you need to scale a replication controller that is named my rc. And then you specify replicas equals 4. So earlier you saw that the replicas was set to 3. Now I'm setting it to 4. So now your replication controller has been scaled. So if you do kubectl get pods, you can see 4 pods that are running that are managed by your replication controller. Yeah. So coming to replica sets. So replica sets are basically the same as replication controllers, but with one additional feature of having better label selectors. So with replica sets, you can have something called match labels, where you just specify the key value pair of labels, and then there is something called match expressions, which lets you specify complex expressions that need to be satisfied for the pod. So basically this is basically saying the key n needs to be there and the value for that key should be def. So there is another expression operator that just lets you define an operator called exists. So this doesn't need to be there. So I can just say n exists. Then it will manage all the pods with selector key having env. It doesn't. It can be any value. So that is the advantage of having a replica set. But other than that, it's the same as a replication controller. Now coming to daemon sets, I don't have an example for daemon sets. You guys can explore that on your own. But what daemon sets are is that it makes sure that each node has a single pod running of that of the template that I've provided. So it just runs one pod in each node. Yeah, coming to jobs, that's another component in the cluster. So there are 3 examples provided here. Pod A is unmanaged. So this is an event where one of the nodes fails. So pod A is unmanaged. When node 1 fails, pod A is not restarted by anything because it is an unmanaged resource. Pod B is managed by a replica set. So when it is managed by a replica set, when node 1 fails, it schedules it in node 2 because it has to keep that pod running. Now pod C, which is managed by something called a job, which is similar to a replication controller. It is something that manages the pods. So pod C, which is managed by a job, when node 1 fails, it schedules it in node 2 and keeps it running as long as it needs to run, because a job is something that runs for a specific amount of time. It doesn't keep running. It runs for a specific amount of time and it finishes execution. After that, it doesn't need to keep running the pod in the cluster. So coming to the demo, this is a job. So as you can see, the API version is different here. And then, the same thing as in all other manifests, you define the metadata as the name, and then you provide the specification. So there are two additional parameters here, which is completions and parallelism. So what completions and parallelism are is that this makes sure that 5 instances of your job are created, so that the job is done 5 times. And then parallelism is when you specify how many pods need to be running at the same time. So what it does is that it runs your job 5 times, but at once 3 pods are running. Yeah, so and then you provide the template the same way as you would provide in a replication controller or a replica set. So I can create a job in the cluster. So now you can see jobs. Yeah, so completions tells you how many times your job has been completed, and it has to complete the job 5 times. If you do kubectl get pods, yeah, so you can see here that there are 3 pods that are running because I've specified the parallelism as 3. So this will take some time. I'll delete the job and I'll demonstrate another thing. Yeah, so if I edit the job to have parallelism as 2, and then I create it in my cluster, and then you do kubectl get pods. Yeah, so these 2 jobs are being terminated because I just deleted the job, so it takes some time to terminate that job, and it is creating 2 new jobs, and it's creating 2 jobs because 2 job pods because I specified the parallelism as 2, so it has to run 2 pods at the same time. Yeah, so that is jobs. Yeah, and then there is something called a cron job, which you guys might have heard that you would normally use in your machine, but there is something called a cron job resource in Kubernetes where you can specify, okay, run this job at this specific time of the day or something like that. Yeah, so coming to services. So there are pods running in your cluster. Say there is a pod running Nginx in your cluster. How do you access that service from within the cluster or outside the cluster or anything? Because that pod could stop because of a node failure or something, and your the replication controller or something will start that pod in any other place. So it will have a different IP, right? So if the IP of the pod keeps changing, then how do you know where exactly to access this pod? So what you need to do is you need to create a component called a service, which basically is something that exists like in front of your pod, and you can access the service which forwards your request to the pod. So you can have multiple pods that are running, and all of them can be interfaced with the service. So here there's an external client, and he's trying to access this website basically, and then he's trying to access the front end service with like a constant IP. It doesn't change. And then this request is forwarded to one of these pods, and then even within your cluster, this front end pod will try to access the backend through something called a backend service. Coming to the demo. Yeah, so this is the manifest for a service. Yeah, same thing as before, and in the specification, again you specify a selector because you want your, like all of these pods, they'll all share a label which you specify to the service so that it will know which pods to interface. So here I've specified app, my app and ndev as the selectors, and then you specify the ports. So here basically there is something called a target port. Target port is the port which are exposed by these pods, so that your service will know which port to forward the request to, and this port is the port with which you access the service itself, and then you specify the protocol, which is TCP. So I can create this service. Okay, the service already exists. Yeah, So I can create this service, and then I can view that service here. Yeah, so you can see my service here, and then this is the cluster IP. So right now I can't access this IP from my local machine because this is from within the cluster IP. Like I said, Kubernetes creates its own network, so this IP is not accessible from my local machine. It is accessible from within the cluster. So I can demonstrate how this is accessible from within the cluster by creating another pod, and I'm going to make a request from that pod to this service. So there is something, I've written a manifest for a curl pod which has the curl installed in it. So I can just create the curl pod. Okay, the curl pod already exists. You can see that pod here. Yeah, the curl pod exists. I'll just delete. Yeah, so the curl pod exists. Now, if you guys remember how Arfath exec into the Docker container, it was basically docker exec -it, yeah, and he did that. So you can do the same thing in using kubectl. You can exec into a pod, and you do that by doing this kube exec -it curl pod, and then you specify the what shell you want to run. Yeah, so exec into the curl pod. Now I will copy this this cluster IP. I will try to access this. So as you guys remember, this is the port to access the service with, and the IP is this. So all I have to do is curl 8080. Yeah, so this is the Nginx page basically. So I'm able to access the Nginx pod that is running within the cluster through a service that is interfacing the pod and with a constant IP. Yeah, so that's basically service. So there are other services. This is a very basic service that you can create in your cluster. But there are other more complex services that you can create called node ports and load balancer. So this is how a node port works. So what a node port does is it creates a service which interfaces the ports that you want, and then also it exposes a specific port in all of your nodes, so that the external client can access those ports from outside your network. So as you could see here, you couldn't access this IP from my local machine because it is cluster IP. It is running inside the cluster network. But if I want to access it from outside, I have to create something called a node port, and this is a manifest for a node port. So it is a service itself, but you specify the type as node port here, and then you specify selectors so that it will know which ports to interface. And then the ports is the same as before. So I've already created this node port. So you can see here my NP service is the node port service, and this is the cluster IP. So because I'm running my cluster in Docker, I would have to get the Docker container of the control plane. I would have to get the IP of that, which would be the IP of the node, because I am running my node as a Docker container. So to get the IP of the node, I'm just going to exec into the container, and I'm going to do IPA to get to get the IP of the Docker container, and then I'm going to do this. So to find out which port it has been allocated, I can see here it's 30080. So if I do this, I can get access to the pod that is running Nginx. So basically what is happening is my local machine is making a request to the node port service, which is forwarding the request to the specific port that it creates, and then from there it goes to a service that the node port creates, and from the service it goes to the pod. Basically this image right here. Yeah, from external client to the port to the service to the port of the pod. Coming to load balancer, a load balancer also uses node port, but it does load balancing between the node ports. So you don't have to you don't have to make a request to a specific node itself. It will do load balancing between the nodes. So a load balancer is a wrapper on top of node port. So if you create a load balancer, it creates a node port which opens up a specific ports in your nodes, and then a service that is created in the cluster which forwards your request to the pod. So these are like multiple levels that are created. So I can show the load balancer service manifest. So it's the same as before. You specify the type as load balancer, you specify selectors, and you specify the ports. I've already created the load balancer service here. So when you create a load balancer, it should assign an external IP. But since this is kind and not really like an actual cluster in production, it won't assign an external IP. So what you would have to do is you would have to do port forwarding again. So the way you do port forwarding for services like this. Yeah. So you can access. Yeah. So you're basically accessing the load balancer service, and then which is port forwarding it to the. You're doing port forwarding from localhost to your load balancer service, which is doing all of those multiple levels of request forwarding. Yeah. Okay, coming to configs. So say you are running a pod and you want, there are certain parameters that you want to be defined in the environment of the pod. If you guys have heard of environment variables, if you want to define those in your pods, there is a way to do it in the pod manifest itself. But you don't want to define all of those parameters in the manifest. You want to create another component in the cluster, and you want to get all of these parameters from that component. So that is what a config map is. So your pod is running here, and there's a container, and then there is something called a config map, which is defined in your cluster, and then there is key 1, value 1, key 2, value 2. Those environment variables are defined using this config map. So the manifest for the config map, yeah, it's like this. So you define data, and then you define a key value pair basically. And then to create a pod with an environment variable, you define env here, and then you give a name to the environment variable, and then you specify that the value for the environment variable should be fetched from the config map with this name and this key. So you specify. 1 minute. Can you give my charger? Yeah, so the value for the environment variable is fetched from the config map. So I want to create this config map resource in my cluster. So I do this. Okay, the config map is already there. So you can see that the config map is there here. So my config, that has been created. Now I want to run the pod that fetches this as an environment variable from the config map. So I do, so this pod has been created. You can see that here, my pod for CM. Yeah. Okay, I think there's a problem with it's terminating as soon as it's starting. Okay, the reason it's terminating is because I've defined a replication controller with the number of replicas as 4, and since there are already 4 replicas running with these labels, it is deleting the pod as soon as it is being created. So to delete, to make sure that this doesn't happen, I'll just delete the replication controller. So now if you do kubectl get pods, yeah, you can see those pods aren't running, and then I can create my config map pod. Yeah, so that is running. So to see whether or not the environment variable has fetched that value, I can just do my pod for CM, and I can exec into the pod. So to check if it actually created, this is the name of the environment variable. I'll just do echo and the name of the environment variable, and then I can see that the value matches what I have given in my config map. Yeah, my config map is my env var value, and then you can see that it's defined here. So that is config map. There are something called secrets. So a secret is basically something that you don't want you want it to be secure. You don't want certain data to be accessible by everyone, so you define something called secrets. And the way secrets are secured in your cluster is there are something called service accounts in your cluster. So when multiple people are running services in the cluster, you want to assign specific roles to each of those people, and you create something called service account, which is basically like accounts for each person in the cluster. So the same thing applies here. A pod is assigned something called a service account, and that service account is given certain privileges, and one of those privileges would be reading a certain secret. So that's how secrets work. It's the same as config maps, but with an extra layer of added security. So this is a secret. So you specify this secret here like this. Is there a pod for this? Yeah, that's fine. Yeah, so you can just create a secret like this, and then you can see the secrets that are in your so this is the secret that has been created in a cluster, and the way you mount a secret is similar to the way you mount a config map. Yeah, so one last thing that I want to cover is namespaces. So in Kubernetes, you can run your pods within certain namespaces. So if I do kubectl get ns, yeah, so these are the namespaces that I get. So if I want to run a pod named my pod in the default namespace, I can't run another pod that is named the same thing, because it is defined for that namespace. If I wanna, I can run that in another namespace. So that is one of the features of namespace. So if I do kubectl get pods, by default it lists all the pods in the default namespace. But if I wanna get pods, say this is how you do it. Yeah. Kube system. Yeah, so these are the pods that are running in the namespace kube system. So these are the pods that are specific to the control plane. You can see etcd is being run here, API server, controller manager, scheduler. Yeah, so these are being run in the kube system namespace. Yeah, so those are some of the basic components in Kubernetes. There are other things that you guys need to explore in order to get more in-depth knowledge of Kubernetes. One of those are volumes, and if you guys are familiar with Docker a little bit, then you guys will know there are something called Docker volumes, and this is very similar to that. But Kubernetes has something called persistent volumes and persistent volume claims. Those are some things that you guys would need to explore. And then how secrets work with regards to service accounts and role-based access control and everything. And then there is something called ingress controller, which is another kind of service, which is a little bit more complicated that you guys could explore. Stateful sets are very similar to daemon sets, replication controller, and replica sets with an added feature. Yeah, and then roles and role bindings that you guys can explore in Kubernetes. So coming to some of the other tasks that you guys can do in order to have more experience with Kubernetes before you guys attempt the ISC task. So there is a website called Code Cloud, where you guys can do some challenges with regards to, related to the Kubernetes deployments. Yeah, so this is free. You guys can try this out. These are basically labs. They'll give you, they'll set up the entire environment, and they'll tell you to deploy certain architecture in the cluster. Yeah, and then there is another lab-based challenge. So there'll be like a faulty pod that you'd have to fix. So all you'd have to do in these is you'd have to like modify certain manifest files, like the YAML files that I just showed, or you'd have to create new manifest files. Yeah, and then there is one article that is about deploying WordPress on your cluster. So this goes in depth about creating all the services that you'd need to create, like MySQL service, and then the service that you'd need to create for that, and then secrets, persistent volumes, persistent volume claims. Yeah. So this is very helpful to understand how you would need to deploy like a web service in your cluster. Yeah, so these are the prerequisite tasks. We'll be rolling out the actual ISC task soon, and we'll be making teams, and then you guys will be participating in the IST, and then solving the task in that team, and then by the end, we'll give some goodies for participation. Do you guys have any doubts? The people who are online, do you guys have any doubts? Anything that you guys want to be clarified? So if you guys didn't understand anything here, that's fine. This was supposed to be like a very high level overview of Kubernetes. It can't be covered in like 1.5 hours or 2 hours. But you guys now know that there are something called pods, services, load balancers, node services, replication controllers, daemon sets, and everything. You guys can now go and explore and play with your own Kubernetes cluster. So what you would need to create, what you would need to install is, you'd need to install Docker, you'd need to install something called kind, and then you'd need to install kubectl. These are the 3 things that you need to install, and then after that the Kubernetes documentation is pretty extensive, where you guys can get example manifests and create resources of your own in the cluster. So if you guys do this, you'll have like very good knowledge of how to deploy things in your cluster, and then you guys will be able to attempt the task. Any other doubts?